Hello and welcome to the very first programming video on this channel. And here I just wanted to make an idea come to life. It is inspired by Soding's no build and the zig build system. Basically executing compile commands for C inside the C programming language. And I kind of wanted to dabble on that as well while um exploring on my own. Just me and the manual pages. So this would be on Linux only for now. But we will start with only the foundations for now. And then we'll go on every episode. So let's create the directories for this part. And the directories for the other projects that will soon come if I have more ideas like this in the future. Offline projects. So what can we call this? If sorting calls it no build and the zig build system is called like that, then what can I add? And basically it would be not an external build system that would require other program like cmake, make, something like that. Just the compilers, linkers, and archivers. So no build. Mm, but technically, I would be making a build system. So I guess let's just call it no external build system in this app, disregarding the E and using the other letters as starting acronyms. No beta. Yeah, that sounds good. So this is my first project. No beta. Ah, I have no git config here. Oh well, let's just rename the branch to main. And let us start by defining our to-dos and the git ignore. Since this is a C project, most of the time object files will be running while the libraries and the executables. What I want is for this thing to compile down to a build file, usually called /build. So that should be excluded. And well, we better have our test source. It's called main that would just say hello world, the usual. Standard IOH. Hello world. And return successfully. There you go. What I want are no external build system in this app. And then the to-dos. First, let's make this a header only library like Soldings. based on nothing's STB. Not like I'll be adding any other standard. Uh, I mean, adding something atop the standard library. Still, I want this to be able to build an executable and then a library. Then what do most build systems have? It rebuilds based on the last modification times of the source files and the output files. So rebuild based on the last modification of the source and output files. Then, instead of just building the executables directly by just appending every source file, we got to build it first into an object files. Build to object sources to object files first, then link. And from what I know, I can only just use C in sync with only one processor. Well, that's only my experience, but well, let's try to learn multiprocessing here. Maybe not exactly multiprocessing, but multiple commands to occur at once. So we gotta utilize that CPU, you know. And what else? The build systems usually output to user bin, user lib. That's right, the prefix directory. Support the prefix directory. But well, we'll save multiparsing for last. Well, maybe I want to be cross-platform too. That would be the true last thing here. Supporting Linux, Windows, and Mac OS. That would be all for the to-dos until I think of something else. Right now, I would only use for a bit of Linux. So let's start actually coding. It first comes with a header guard. Oops. Define, if not define, if I can only just use pragma once. But I don't really like using that as I'm more used to this. So what would be the API? Zig returns some target variable that you can modify with other functions. So we'll go with that. What do we call this? Let's just call it nobita target. And disguise it as an executable. A library. Well, libraries have shared and static. So it can be shared. and static. But if you want a dynamic executable and a shared executable, you can just define dash static or not in the C flags. So that will be fine since I'll allow you to define C flags yourself here, even the compiler. But the problem is in the shared library, you can just let the compiler do the work to make it, to link it together. But for the static library, you need to define what archiver you're going to use. And the add functions. You get the executable definition from add exe. I guess that would be a good enough name. But Zig passes a build variable into its main build function. So yeah, let's copy that as well. Just call it beta build. And you can set the name of the executable here. And of course, don't forget the library static. Oops, I've done that wrong. There you go, way better. Next up, you can set whatever compiler you want, but it needs to be able to take all of these three types at once. So instead of just compiler, it has to be combination of the compiler, the linker. Well, the compiler already calls the linker. So just the compiler and then the archiver for the static library. And then the logic can be inside this function to allow the archiver to be null if it's not a static library. So nobita instead of build, then target set, no, not set compiler, but set build tools. And it would take the struct a beta target and the constant C compiler and the archiver. But I don't know what kind of compiler you will give me. You will give this build system, so you got to set the options. Set build tool options. What do I want? For the C compiler, to be able to facilitate the object files first, I need the dash C option, or like the dash C option for GCC. And we can call that, I don't know, CC to object, opt, and then I want the output file option for the C compiler, and that should be called something like, what to call this? I don't have much confidence on my name sense. Let's just call it out file opt. And then for the archiver, I need the options to create the static library. AR create opt. Now we get to the main parts, the compile options. The main compile options. Add C flags, the compile flags. T, and then, yeah, that can be a variadic function. Good luck with the file size later. Then the sources, and then the link flags. I think that's good enough, I suppose. Wait, I guess these options would allow these, and then these. And this could be the implementation. Ah, yes, the prefix directory. We can add that. We can set that here. Set prefix. This better be an absolute path, you hear me? Well, we can just check that later. But for now, we'll just setting the foundation. Now the main part for header only library is the implementation. Impl. So you define this and then this becomes a source file. Or this gets treated as a source file. Though what you will define in your build is not mean, but what do you call this? The build function. Like this, the void build, then nobita build b. But right now, that ain't really needed. So yeah, but it's good to know. So if the target can accept multiple C flags, sources, LD flags, a single prefix, options, the build tools, and the main build can accept multiple executables and libraries. Yeah, we're gonna need a vector or an easily growable array. And if we're going to have multiple pointers that we need to grow inside these structs, yeah, I'll just go with macros. Let's define that to get the support of clang D. just call it vector init or something. Then the pointer to the string. And then what else? Since I cannot just use the normal used and capacity, since there will be multiple, we can just concatenate it to the name of the actual pointer inside the string. Let's put that inside a do while. So that it can be an isolated one-liner when called as a function like macro. So for this pointer, we set name to be allocated. And we just set 8 as the default. But maybe it's better to call calloc first. So it would be zeroed out just in case. And what we want is the size of the data. So we can just dereference the actual pointer to the data. And actually set the correct sizes and concatenate the pointer name and size. Set that equal to 8 and use that should be 0 as there's supposed to be nothing there yet. And for an easy way to check if this is null and fail immediately, you can use assert. Though, is it recommended? No, not really. But this is just a for fun project until it becomes a serious project. And then, what funny message should it be when calloc fails? It means you're out of memory and the system cannot give you more, so yeah, just buy more RAM, man. I cannot really do anything if the system cannot give you more memory, you know? Well, if there's init, there should be free. But we can just easily copy it and save free pointer to name and set size to 0 and set name to null. So doesn't do anything anymore. And you got to append something in there. What use a vector? What's the use of the vector if you cannot put items in it? Of course, we're gonna use macros. Init, just append. Actually put the item in there. First, let's go with the appending logic. Of course, the amount used would increase by 1. And you need used. So you take the current index at used in the pointer name and set it to item. There you go. That's easy appending right there. Since it starts at 0, you set index 0 to item and then use is now 1. Then next, it sets 1 to the next item and then increments. But we got to resize it too if it gets full. So you gotta set up the logic for that. You gotta check the size. Size. Check if it's less than or equal to used plus 1. But in the worst case, the moment that this gets triggered, it will only be equal to size. But yeah, who knows what could happen. So what one is create a new allocation. You'll be using calloc since I want it to be set to 0. Then at the next size, I want it to be double that, double the size of the current data. Of course, you gotta assert that it's not null and say you gotta buy more RAM if it fails. Then you gotta copy the current data, which is in the pointer. The size would be, well, the pointer to name. But that's not enough. We gotta copy the amount used as well. Name used. There you go. It will copy every single thing in name to data correctly now. And then you set name to the new data. But first, you gotta free the current data. And most important of all, you gotta increase the size. Don't ask me how I know why this is the most important. Okay, that's done. So yeah, well, we can just call it, just call build from here. Well, that vector would be available here. Since everything in the source file is available here, we can just, test it for now. By the way, what's the current time? 30 minutes. Well, just gotta have a normal strap. See? Like, you know, int nums, st nums used, and size. Struct c a, and then vector init a and c. No, it's called nums. But it should be a pointer. And then you gotta free it. And inside, for example, in I equals 0, I is less than 1024, I plus plus, and you can just append I, append a nums I. Of course, it needs the pointer. Hmm? Did I not include the one for memcopy? Yes, I did. Strings, string.h. There you go. Two. Of course, we gotta print it. Since I use I size T, gotta print it all. And for the int, it's just the a nums I. Gotta include standard IO. There you go. GCC build Linux. Wait, I should have used all my warnings and gave it the debug and ASAN just in case. Hmm? I forgot the I. Alright, let's do this. Okay, I did it up to 1023, which is correct. And 1023 here multiplied by 2. And surprisingly, ASAN did not complain. So for now, we'll end it here with a dynamic resized array. Thank you for, thank you for going along with this with me.